share the paper. Okay, let's start to do this paper. 2018. Okay. First one, answer all the questions in the spaces provided. The model of nuclear atom was first proposed by Ernest Rutherford. He developed this model on the basis of results obtained from an experiment using gold metal foil. You know, Geiger and Marsden worked under Rutherford for this experiment. There was their very first theory introduced, nucleus. Complete the table with information for two of the particles in an atom of gold 197. Electron relative mass, location within atoms is in shells, energy shells. Shells. Total number. Okay. Neutron relative mass is 1. Relative charge 0. It's in nucleus. Total number in atoms. So you know, it's not an atom. It's not an ion. It's atom. Which atom? Number of electrons and number of protons are the same. And here 197 is mass number. Mass number is generated by neutrons and protons. So already we know there should be 79 protons. So how many neutrons are there? 197 minus 79 equals, yes, good. 118, no?
Yeah.
Okay. State the type of bonding in gold. So gold is a metal.
Yeah.
So it's a metallic lattice. Sample of gold found in Earth consists of only one isotope. Explain what it's mean by the term isotope. Yeah. Isotopes are the presence of different mass atoms in same element. Presence of different mass atoms in same element is called isotopes. And you know, mass is different because the number of neutrons are different. Number of protons are always the same. Otherwise, the element is not the same. So the only difference is number of neutrons. However, when the number of neutrons change and mass changes, all the physical properties change, but chemical properties remain the same. Because chemical properties only depend on electrons. That is the short note on isotopes. But for the answer, no need to write like that. For the answer is presence of different mass atoms. In brackets, you can write due to different number of neutrons, close the bracket, and due in the same element. That is the answer. Okay, different sample of gold contains more than one isotope. Suggest why did this different sample of gold has the same chemical properties? Yeah, so chemical properties, because they have same number of electrons. Chemical properties only depend on electrons. So we can say electronic configuration. So they have the same electronic configuration. So same number of electrons. Tumbaga is an alloy of copper and gold. Sample of Tumbaga was analyzed. Mass spectrum of sample is shown. Okay. Calculate the percentage abundance of gold in the sample. The percentage. It's just because it's percentage, total should be 100. So copper and sample of, okay, gold sample. We don't know molar mass. We don't know relative atomic mass. So we can't do any calculation there. So I think abundances addition should be 100, no? We can't now. We can't do a calculation because we don't know the relative atomic mass or relative elemental. If you know relative elemental mass, then we can write like 60, like 63 into 56.36 over 100 plus 65 into 25.14 over 100, like plus the other one equal to relative atomic mass, but they don't give any relative atomic mass. Actually this is allowed, so that means this is just 100 minus
25 plus 56.3.
yeah, this is plus 25.1. That's the only way. There's no any other way to do the calculation. Okay. Good. Calculate relative atomic mass of copper present in this sample. We can do that. Give you answer. We can do that because we have the abundance and everything there. So there we can do that calculation. 63 into 56.36% plus 65 into 25.14. It's not percent. Wait. We should take this total, isn't it? 56.36 plus 25.14. Right. 81.5. We should write from 81.5 because that's the total. 81.5. Yeah. We can do like this because inside 100 there is not only copper, there is gold also. So don't take it from as a percentage. Take it from how much? From 81 point. Okay.
Yeah.
Is your exams cancelled here in Sri Lanka? Cambridge exams cancelled.
For October, November.
Sorry?
For October, November, or for May, June?
October.
No, I don't think so. No.
Here, in Sri Lanka, it's cancelled. That's why I asked. Okay. Okay, this way is okay, no?
Is it official that they cancelled?
Yeah, it's official. Now EdXL ones are waiting, but they also don't know what happens. It's on October 5th, but they don't even get the application. But EdXL, they didn't say, but Cambridge for sure they said it's gonna cancel, because all my students in here told me last week that it is cancelled.
Yeah, it's not cancelled.
Yeah, maybe. Only I think it may be only this region, for this region.
Yeah.
From this you can take the answer. Let's move. Okay, no problem. This one. The table gives some data for elements in the third period and some of their type of bonding: sodium metallic, magnesium metallic, aluminium same metallic, all are metals metallic, silicon covalent bonding. Formula of oxide, they need the highest oxidation number oxide, so Na2O, MgO, Al2O3, silicon SiO2. Formula of chloride, AlCl3, SiCl4, PCl5. PCl3 is also present, but I wrote the chloride with highest oxidation state. Complete the table to show the bonding in elements. Okay, we already did. SCl2 is formed the following reaction. Okay, it's an exothermic reaction. When the reaction happens, energy is given out forward one. That means reverse one is endothermic. Okay. Complete the dot and cross diagram to show bonding in a molecule of SCl2. Okay. So this is sulfur, chlorine, chlorine. There are two bonds, dot, cross. Let's think dot is from sulfur, cross is the electron from chlorine. Sulfur should has its own 6 electrons. 1, 2, 3, 4, 5, 6. Its own 6 electrons because it's a 6 group, and total is 8 electrons. Chlorine has its own 7 electrons and total is 8 with the bond electron. Not hard. Okay. Then complete and fully label the reaction pathway diagram for the reaction between S2Cl2 and chlorine. Include labels for activation energy and enthalpy change of the forward reaction delta H. Good. This is always there. Forward reaction is exothermic, so the line should come downwards, no? Exothermic.
Yeah.
And products are SCl2. SCl2. You know, the minimum energy we should supply to happen the reaction is activation energy. The reaction barrier, it is EA. The energy difference, the enthalpy difference between reactants and products is called enthalpy difference. It is delta H, and here it's a exothermic reaction, so delta H is a minus. This is exothermic. So the minimum energy difference, the energy difference between reactants and products is enthalpy, and enthalpy cannot be changed by anything. It's a constant. constant always. Activation energy is the minimum energy we should supply to happen the reaction, and we can change it using catalyst. If we use catalyst, activation energy decreases and reaction rate increases. But enthalpy change is always a constant. You can never change it. It's a constant for that particular reaction. It only depends on the mechanism. It's a good knowledge here. Okay. And if the forward is XO, reverse will be endotherm. Okay. The axis sketch trend in melting point for element sodium to sulfur. It's a good one. From first group, it increases. It will increase second, third, because the metallic lattice strength increases with the number of electrons released increase, and fourth group always has the highest. If it is carbon, carbon. If it is silicon, it will be silicon, because they form a very strong giant atomic structure. Then phosphorus shows a lesser one than even sodium. Then sulfur lesser than even phosphorus. Wait. Sulfur will show a, normally in other periods it's like that, but because it's sulfur, it will show a higher one than phosphorus. So it will be like here and like this. Yeah, that's better. Metallic lattice increases because the charge increases. Then fourth group is always the highest. Then fifth group less. Then sixth group should be lesser than that. But sulfur is S8 molecules, not giant lattice, but it is greater than phosphorus. So something like this will be. But sulfur should be lesser than sodium, because sodium is a metal and it has a metal. This was this even our target. This is a target for us also, for the upcoming exam. Give 3 statements to explain your sketch. So we can say in metals from first group to third group, melting points, boiling points increase because metallic lattice increases when the cation charge increases. Then fourth group element has the highest melting point or boiling point because it forms a giant covalent atomic structure. Fourth group element forms a giant element covalent structure, so it has a highest. And phosphorus sulfur are simple molecules. They have a lesser melting point, boiling point than all the others, but sulfur has a higher, even phosphorus and sulfur are simple molecules. Sulfur has a higher melting point or boiling point because sulfur has stronger interactions than phosphorus because mass of sulfur is high. Because in nature, sulfur stays as S8, but phosphorus as P4. 8 sulfur atoms are staying together. Only 4 phosphorus atoms staying together when they are in the nature. So sulfur has a higher mass in nature. So that's why sulfur is greater than phosphorus due to the strength of secondary. That's a good knowledge. Okay. P4 or 10 in water. So here phosphorus is in oxidation number 4x minus 20 equals 0. Plus 5, ne? Plus 5 oxidation state. That means the highest oxidation state of phosphorus. It will form plus 5 acid. 4 phosphorus should be there. 16. 6 here. Yes, that's that one. Anything if you mix in water, hydroxide will be formed. It can be acidic-basic, however, the same oxidation number, hydroxide, will be formed. Okay, then SO2 can be released into atmosphere. Fossil fuel containing sulfur burn. State and explain one and consequence. Yeah. SO2 forms acid rains. You know, SO2 dissolves in water and forms H2SO3, and SO2 plus O2 plus water forms H2SO4. Acid rains are generated. Acid rains does a very bad ill effects, too much ill effects to environment. Like there are many, so washing away all the nutrients from the soil, eutrophication, corrosion of metals, deterioration of buildings and metals, killing of water habitat. Like that, there are many. Okay. Elements in the third period show a general increase in their first ionization energies from left to right. Identify two pairs of successive elements third period that do not agree with this statement. For each pair, explain why the change in energy does not agree statement. So, this question is always there. For this type of question, we should know the pattern. First group, first ionization energy pattern. Second, third, fourth, fifth, sixth, seventh, eighth. Now you can, now earlier, in earlier days, scientists thought because radius decreases, it is a general increment. But then scientists knew general increment changes in two positions, in these two positions, third group and sixth group. So I think we are very familiar with these types of questions. Why general increment is contradicts in third group and sixth group? Third group it becomes less. First ionization energy becomes lesser than second, and sixth group first ionization energy becomes lesser than fifth. Those are the two contradictions for the general increment. But how can we explain that? First one is second group has S2 electronic configuration, but third group has S2P1. S2 is so much stable than S2P1. So the energy we should supply to take out an electron from S2 is greater than we think. That's why relatively second group ionization is greater than first group. Again in fifth and sixth, fifth group element has S2P3. P orbitals are halfly filled. That is a stable electronic configuration. But 6 electron 6 means S2P4. It is much less stable. Again, fifth group is more stable than 6. So first ionization energy is greater than we think. Is it okay?
Yeah.
It's very common question. Trihalomethanes are organic molecules in which 3 of the hydrogen atoms of methane are replaced by halogen atoms. Equation shows a reaction to produce CHF. Use the data to calculate enthalpy change of reaction for this formation of CHF3. So they gave you all the formations. So you know when they give you all the formation enthalpies, you can take the reaction enthalpy by total formation enthalpy of products minus total formation enthalpy of reactants. So total formation in reaction enthalpy equals total formation enthalpy of formation is a products minus total formation enthalpy of reactants. So products there should be 3 AGI. So 3 into 1 AGI formation is minus 61.8 plus CHF3 minus 692.9 total formation minus total formation of reactants minus 182.1 plus 3 AGF 3 into minus 204.6. You can put kilojoules per mole later. Like that. Total formation enthalpy of products, but you have to multiply by that number of moles. Stoichiometry. If it is 2, you have to multiply by 2. If it is 3, by 3, half, half, like that. So, however, total formation enthalpy of products minus total formation enthalpy of reactants gives you reaction enthalpy. That method is the important one. Otherwise, it's just a calculation. You can do it. Okay. We can move to the next part. Good question. Graph shows relationship between PV and P. Yeah. Yes. CHF3 is not ideal gas. Yes. Everything in this world are real gases. There is no ideal gas in reality. State three basic assumptions that scientists make about the properties of ideal gas. It's very easy. Properties of ideal gases. So one assumption is there are no interactions between gas particles. Number two, first one, there are no interactions between particles. Number two, uh, all collisions are totally elastic. Number three, gas particles are point masses. We think ideal gas particles are point masses. That means they have a mass, but there is no volume. It's not real. It's not reality, really. In reality, there is a volume, but we assume that they are point masses. They have mass, but no volume. There are many other, like assuming they are spherical solid spheres. Newton laws are compromised. There are many more, but that 3 points is enough. Sorry.
No.
Okay. Explain why CH3 deviates from properties of a pressure greater than 380. Yes. It's like this. When pressure is now even lesser than 300, it is then downwards, but then it's upwards. Now, actually, the higher the pressure, the nearer the gas particles. The higher the pressure, the nearer the gas particles. The nearer the gas particles, more attractions are generated. The nearer the gas particle, more attractions are generated. So it should be more away from the ideal situation. When we increase the pressure, gas particles come more and more near to each other. Then it forms more interactions. So more interactions means it deviates more from the ideal situation. That's the explanation. Okay.
Yeah.
Infrared. Different trichlomethane reacts with oxygen to produce carbonyl dichloride. HCl gas is also released as a product of this reaction. This is carbonyl dichloride. Write an equation for this reaction of CaCl3 with protein. They ask us to write a reaction. So CaCl3 plus O2 forms COCl2 plus H2O. No. They say HCl gas is another product. HCl. I think it's balanced. No, not balanced. You have to put 2 here. Yes, 2 here. Then 2 here. 2 here. 2 here. I think now it's balanced. Okay.
Okay.
Conversion of CaCl3 to carbonyl dichloride can be monitored by infrared spectroscopy. Infrared spectroscopy of carbonyl dichloride. Okay, carbonyl dichloride. That 1700 peak is for C double bond. It's there. It's visible. On the infrared spectrum of carbonyl dichloride identify with an X the absorption that would not be present in an infrared CaCl 1700 per centimeter. Why? 1700 per centimeter is for C double bond or carbonyl bond. This is this. It in CHCl3 bond you can't see it. In CHCl3 in CHCl3 there is no C double bond, so that's how we take it. Even in the real formulation chemistry, that is how we think whether the end product is formed or not using infrared rays. Okay. Suggest another difference between infrared spectra of CHCl3 and carbonyl dichloride. CCl bond is there. No? CH bond. CH bond is only there in CHCl3. So in CHCl3, it will give a CH bond peak, but in CCl2CO, there is no CH bond peak. That's another difference. Okay. The diagram shows a reaction sequence starting from ethanol aldehyde. Draw the displayed formula of P. Ethanol hydrogen cyanide to ethanol forms cyanohydrian product. What is the main importance of a cyanohydrian product? That's the only reaction where there are two functional groups. Two functional groups comes in one step reaction. OH group is also there. Cyanide group is also there. Two functional groups in one step. That's simple. So yes, that's the product. That's P. Name the type of chemical reaction that occurs in reaction 3. 3 OH and H goes out and a double bond forms. It's a dehydration. Water molecule is going out. Dehydration or elimination. The real mechanism name is elimination. In general, we call it dehydration. So both answers are okay. But if they ask the mechanism, don't say dehydration. Mechanism name is elimination. OH and H goes out to form a double bond. But they just ask the reaction, so dehydration is fine. Write an equation represent reaction 4. Use O to represent oxidizing agent. Reaction 4. It's oxidation. CO, that alcohol carbon becomes a carboxylic carbon. No problem. It's oxidation. You can write the same with O here. There's no other difference. With O here, you can write down same. State the regions and conditions for reaction 4. We can add a strong oxidizing agent like acidic KMnO4, dichromate. Yeah, things like that. It should be strong, however, with LD alcohol to ketone. Compound Q is formed as mixture of two optical isomers. This is what is meant by term optical isomers. Yes, optical isomers are isomers which have the same structural formulae, but due to the chiral carbon, but due to the presence of mirror image isomer, or just we can say molecules with same structural formulae but having mirror image isomers, but having 3D mirror image isomers called optical isomers. Actually, what optical isomers does is one molecule deflects the plane polarized light to one direction and the other molecule deflects the plane polarized light in the same degrees to the opposite direction. That's what they do. They deflect plane polarized light in opposite directions, but in the same angle. Those are optical isomers. Draw the two optical isomers of Q by 3 dimensions. Yes, so if they want 3-dimensionally, COH, COOH, one out, one in. Here C, one out, CH3, one in, H, OH, two twin tetrahedral, two around carbon are in the same. These two are mirror images of each other. Mirror image. We say D molecule and L molecule. Or some say R and L. Okay. And then R can be used to make a polymer W in 2 steps. Addition polymerization, intermediate polymer, NaOH W. Draw one repeat unit of W. Where's R? Okay, R has a double bond, olefinic group, so it generates addition polymerization, no problem. Then it's a polypropanoid. So intermediate polymer. And sodium hydroxide is added. This will be COO minus Na plus W. Repeat unit of W will be CCH H. Here carboxylic should be there, but with sodium hydroxide, carboxylic becomes carboxylate ion. This is the repeat unit. If polymer put N, but it's not polymer here, and this is the repeat unit. This should be the repeating unit. Due to the ionic nature, it will be more easy to dissolve in water. Compound Z is produced from R. Okay. Z can be used in a two-step process to produce 2-amino propane. First step, Z reacts with HBr to form two products. Structure of the product depends on which intermediate is formed. Not intermediate 1 is more likely to form than intermediate 2. Yeah. Intermediate 1 is a secondary carbocation. Intermediate 2 is a primary carbocation. Secondary carbocation is more stable than primary carbocation. Secondary carbocation is more stable than primary carbocation. So normally reactions tend to go through more stable cation. So that's why intermediate 1 is more likely. Okay. When intermediate 1 forms a product of the first step is T. Complete the diagram, show the mechanism for the conversion of Z to T. Include all relevant. Okay. Z to T, so HBr attack. So what happens here is this bond break onto bromine, 5 bond attacks hydrogen. 1 bond, 5 bond attacks hydrogen. And Br minus releases, it takes H here. And now Br minus is here in the medium. It attacks this positive carbon. That's what happens. It can then be converted to 2-amino propane. Yes, this is not a very good method. Normally, to form amino, we should use acid halide method because this gives a mixture of products and we can't only take what we want. It's not a good method, but still we are doing it. We had to add more and more ammonia or amine and less alkyl halide to keep what we need. Otherwise, It is a chain reaction and gives a mixture of products. But it's okay. We still take that we can do this theoretically. Okay. So name mechanism. Yeah. Br goes out. NH2 minus comes in. Nucleophilic substitution. Nucleophilic substitution. Compound S can be reduced by lithium hydride. Complete the equation using structure. Okay. Okay. If you reduce this, C double bond will be HOH, CH2H. So CH3, CHOH, CH2OH. This is the reduction reaction. Other reducing agents containing group 1 metal cations include lithium borohydride, sodium borohydride, potassium borohydride. Strength of the reduction depends on the size of its cation. Give the electron for sodium plus cation. When sodium gives out an electron, it becomes like neon. So it's neon's electronic configuration. That's it. So that's why ionic radius increases down group 1 because the number of shells increase. When number of shells increase, radius increases. That's it. Okay. Okay, we can finish from there.
Okay, thanks.
Okay, bye.